Here we are, second last question of Stats and Mechanics, Year 1, Chapter 10, question 15. Okay, just the challenge question after this one. This one normally gets fun. Right, two particles P and Q have a mass 0.5, 0.4 kilos respectively. Particles are attached to the end of light inextensible string. String passes over a smooth pulley, which is fixed above the floor. Both particles are held with the string taut at about 2 meters above the ground. The particles are released from rest, and in the subsequent motion, Q does not reach the pulley. Okay, so very similar to a previous question we've already had, but that's fine. So we've got P and we've got Q, and P in Q is 0.4 kilos and 0.5 kilos here, okay, and they are a distance of 2 meters above the ground. Okay, I think that's everything that we're told. Write down an equation of motion for P. Okay, let's see what we've got going on here then. So we've got some forces to put in. We've got the tension force on the rope. We've got the weight of P, which would be 0.5 G, and we've got the weight of the Q, which is 0.4 G as well. Acceleration will be going in this direction, okay, and it will be going in this direction on the other side, okay, being the heavier weight of P. Make a decision, which way are you going to have up and down, and which way is going to be plus and negative. Okay, completely arbitrary, we could do it either way. Write down an equation of motion for P. Okay, so we're going to basically do F equals ma on the left hand side of it. So for P we can do F equals ma. So the forces going up are tension minus the forces going down, which is the weight, and that's going to be equal to the mass, 0.5 times A. All right. There we are, done. Write down an equation of motion for Q. Exactly the same, not exactly the same equation, but for this one, the force that's going up again is tension minus the 0.4 G coming down for the weight, and that will be equal to the mass, 0.4 A. Okay, I think that's everything for those two. Right, what's next? B. Find the tension in the string immediately after the particles are released. Find the tension. Okay, well, we could find the tension by basically using these equations and getting rid of A in them. Okay, so we need to do a bit of simultaneous equations. Let's take all of that and do T minus 0.5 G divided by 0.5 is equal to A. And on this side, I will do T minus 0.4 G all divided by 0.4 is equal to A. And because they are both equal, I will now write them out as being equal. Okay, equals T minus 0.4 G over 0.4. Okay, solve it for T then. How do we want to do that? Let's multiply by 0.5 on the right, multiply by 0.4 on the left, and then we start putting it together and getting the T's together. So on the left, we're going to have 0.4 T minus 0.5 times 0.4 is 0.2. So minus 0.2 G is equal to 0.5 T minus 0.2 G. 0.2 G. Yes. Doesn't feel right. Okay, we'll have a look at it. Let's see what we get. Did I do something wrong? I don't know. Let's see then. Right, as we bring that across, that's going to be positive, that's going to be negative. It looks like the tension comes out as 0 because as I bring that across, these have not changed, have they, in terms of the minus and the plus. So let's just have a quick look and a check that we've copied it all down correctly. Mass times the acceleration. Acceleration is the same. Acceleration is positive. On this side, the acceleration was negative. There. Minus A. Look at my direction. Okay, so that should have been a minus A, which means as it comes through here, all of this should have had a big minus in front of it. So a minus T and a plus there, which means this would be a minus T and a plus there. That makes more sense. That makes a minus. That makes a plus. That makes me happier. The other problem was it was cancelling out to 0, which wasn't working for us. So now that we found our mistake, let's have a look. Okay, bring the 0.5 over, so minus 0.9 T is equal to minus 0.4 G. T is going to be 0.4 over 0.9 G, which I think just multiplies out, doesn't it? For 4 over 9 it does. So tension is 4 over 9 G newtons. Okay, right then, with that done, find the tension, did that bit. C, find the acceleration of A immediately after the particle has been find the acceleration of A immediately after the particles are released. What is A? Capital A. I can only assume that they just want you to find the acceleration. There's only one acceleration in the whole thing. That looks like a bit of a misprint for it. Or were they expecting us to say that the acceleration was capital A? Doesn't make any difference. We're going to find the acceleration. It's the same on both sides. Let's use the one I did wrong here. So we use this one. Okay, and so I'm going to put in minus the tension, which is 4 over 9 G. Okay, plus 0.5 G all over 0.5 is equal to A. And so minus 4 over 9 times 9.8 plus 0.5 times 9.8 equals, divided by 0.5, we get 49 over 45. We end up with 49 over 45 A, which equals 1.088 meters a second minus 2. Okay, that doesn't feel right either. Is it a rounding error? I'll put it into the calculator correctly. So minus tension, did I multiply the tension by that? Minus 4.5, we'll come back to it. So yeah, I was looking at this trying to decide what's going on with it, but if we divide it by 9.8, that actually then comes out as 1/9 g meters a second minus 2. Okay, so both answers are valid there. I just didn't leave it in terms of g. They never told you to, so you don't really have to. Okay, so yes, we could probably easily do it with the manipulation of it. In fact, let's do it. So what? Minus 4/9g plus a half g being divided by a half is equal to a. So let's get some common denominators going on at the top there. Okay, and we're going to flip this half round and start doubling as well. So we're going to do 2 times 4/9, still a minus. 4/9 will go to 18s. Okay, so doubling it up, 8/18. Okay, plus over 18s, of course, is going to be 9/18. 9/18. Okay, and that's got a g on it. That's got a g on it. So 9 of them. So that leaves me as 1/9g. Is it? So we end up with 9/18. Where were we? 4/9 minus 4/9 plus 0.5 is 1/18. Yeah, so 2 times 1/18. It's over 18, isn't it? That's where we're losing it. And that becomes 2/18, which is 1/9g. Okay, if you want to see the manipulation of it. If you don't, well, sorry, I've included it. Right, when the particle has been moving for 0.2 seconds, the string breaks. That's unfortunate. Okay, find the further time that elapses until Q hits the floor. Interesting. Okay, we were 2 meters up. Right then, so we need to consider then that as this whole thing starts to move in this direction and this direction, this will get down a certain amount in the 0.2 seconds. That will give me a distance, which will be the distance that Q has got to here. Now at this point, Q will have an initial speed, so we need an initial speed as well coming down from here so that we can see how much further up Q goes before it falls back to its starting position, which would be that distance, and then how far it falls to 2 meters. And then all of that needs to be put into time rather than distance. Okay, that's got a lot of stuff in it. So let's first start with P traveling downwards for 0.2 seconds. Okay, so at that point, let's do a suvat on it and see how far it goes up, or what speed it's doing actually. Let's just do suvat and see what we've got. Suvat, there it is. Okay, so this is for the distance that I don't know. The initial speed, so what's happened? That started tension and strain, find the acceleration when they're released. So we started at a speed of 0. A final speed, I don't know. The acceleration is this 1/9 g. My time is 0.2 seconds. Okay, and this is for the part of, let's just draw the whole thing again. Let's just put it over here for a second. So there's the string, and there's P and Q, and this bit is for in here of the 0.2 seconds bit. Okay, and we can work out the distance and we can work out the final velocity. Okay, so let's work out the velocity, because I think that's the bit I'm actually interested in. So using my Suvat equations, quickly find them again. Suvat with no s in it is v equals u plus at. So the velocity is equal to the initial plus the acceleration 1 over 9 g times 0.2. So velocity is equal to 1/9 times 0.2, which is 145. Okay, so after that 0.2 seconds, let's change color. After that 0.2 seconds, okay, when the string snaps, we get the initial velocity there of the 145g, because it's accelerated to there, string snapped. So at this point, I want to know how, am I looking for time, was it? How much time it takes for me to get to the top here. Okay, so, because it's going to keep moving for a little bit. Okay, so using Suvat, again, for that little bit of free fall upwards. Okay, let's do Suvat on that. And we don't know the distance. I've just said that the initial speed is 1 over 45g. The final velocity will be 0. The acceleration at that point will be slowing down because it's going from the 145g to 0. And the thing that is slowing it down is gravity. Okay, and the time I don't know, but I do want to know. So again, we can use v equals u plus at. So 0 equals 1 over 45g plus acceleration. Now acceleration is minus, because we're slowing down, minus g time. Okay, and so as I come across here, it's going to look like it's going to be 145, isn't it? Minus 1 over 45 g is equal to minus gt, and so 1 over 45 seconds is equal to t. Okay, so now that I've got that, I have got my time in this section. Okay, and so now I want to see how long it's going to take for it to fall all the way down to there, which is going to be quite a distance. So let's see what we can do with Suvat in that section. The distance I don't know. The initial speed was 0. The final speed I don't know. The acceleration will be 9.8, or gravity, and the time it takes, we don't know. So we need some information. What we probably can work out here is all of the distances, because I can work out the distance for this one, which will give me this bit of information in here. It will give me then the distance in here, which will give me this bit, and then those two bits bring me back to the initial starting point, which brings me down the 2 meters. Okay, so this is going on some. Let's quickly find the distances for these 2 bits. So I want something, what's the easiest s to use? U plus v over 2 times t. Okay, so if I just quickly do coming out a little bit so I can see everything. So if we just do very quickly on here, S equals U plus V over 2 times time. S is equal to 0 plus, we found it, 145G over 2 times by the time of 0.2. Okay, and so that gives me an S of, so 45 divided by 2 is 1 over 90. Times by 0.2, 1 over 450 G meters. That seems a bit weird. Then we can do this one, and again I will do S equals, let's see that in there, S equals U plus V over 2T, and so my S is equal to my 1 over 45 G plus 0 over 2 times by my T that I worked out, which was just 1/45. Okay, so this S comes out at, so 1 over 45 divided by 2, the 1 over 90, times by the 1 over 45, 1 over 4050 G, 1 over 4050 G. So both of those added together plus 2 meters is how far I've got to fall coming down here. Okay, so that G is in the wrong place. That G is or there. Okay, so that one plus 1 over 450 is 1 over 405 times by 9.8. Does it give me anything nice? No, not really. Plus 2. Hideous numbers. 40,000. Okay, so basically this one up here is your 1 over 450 G plus your 1 over 4050 G. Is that what it was? 4050 G, yeah, 450 G plus 2 for the 2 meter drop, and that all comes out as 4099 over 2025. Okay, that's when I've multiplied by the 9.8 as well. So with that in mind, how long has it taken for it to fall all the way down there? As well as, don't forget, we will have to add on the time of 145, which was the time for it to go up, and then we're working out the time to go down. So we've got that time, that's the time down here. Okay, right then, so what do I want? I want something with time in it and no final velocity. No final velocity is S, which is such a nice number for us, equals UT plus a half at squared. So S 4099 over 2025 is equal to 0 times t plus a half times g times t squared. Okay, so that one, so 4099 over 2025 divided by a half g will equal t squared. So that divided by 2 times 9.8 feel like this is getting a bit silly there, but we will carry on. 4099 over 39690. 39690. Okay, square root of should give me t, square root of that. Just all of that work to put it into nice fractions, and it gives me something like 0.32136. And that should be seconds, and that also needs to have added onto it this one. So it needs to have the plus 145 plus 1/45 for a total time, since it's snapped, of plus 1 over 45, 0.3435 seconds. So, been looking at this and I didn't like the answer, mainly because it didn't match with what was in the book. I was like, have I done it wrong? And they do it a different way in the book. But I've decided that no, I am correct, but I have made an error in here somewhere, because I was just rerunning it and I think it's come down to hitting a key somewhere wrong as I've come in here. So I think it was as I did this dividing by a half, dividing by g on there. So as I come in here and I do 4099 over 2025, okay, that is its own fraction, and then I'm going to divide it by a half, and what I'm going to do is I am going to move the half away. I'm going to leave that g on the side for the moment. I'm going to take the g off, get rid of all of this, get rid of all of this, get rid of that. I'll leave the plus bit down there. So I'm going to divide by a half or multiply by 5. Don't forget the g is in there. So taking that and multiplying it by 2, okay, you get 8198 over 2025, which I am then going to divide by g to give me t squared. So dividing that by 9.8, that gives me 8198 all over 19845, which of course needs to be square rooted to give me t. So the square root of all of that comes out at 0.6427, okay, which I then need to add on the extra 1/45 of a second, okay, and as you can see I'm already in the 0.6s, okay, and when you add onto that 1 over 45, it gives you 0.66. So somewhere in that first calculation, as I banged it through the calculator, it obviously put something in there wrong, okay, but 0.66 seconds is what it is. Okay, find the further time elapse. There you go. 8.66 seconds. Done.